The machining of flat bottom holes constitutes a large part of what we are known for at PH Tool. These holes appear in many test blocks such as ASTM reference blocks made to E127 and 428 and many other block types as well. In addition, countless application-specific standards employ the use of flat bottom holes at various depths and diameters. They simply make for excellent ultrasonic inspection targets at very predictable and quantifiable dimensions. This video will highlight the many steps we take at PH Tool to ensure that you get a drilled flat bottom hole of the highest quality available. Keep in mind that while some flat bottom holes are only machinable using the electrical discharge machining or EDM process, due to material hardness, hole location, or being less than drillable diameter, we will focus here on holes made by conventional, otherwise known as drilled machining methods using modern CNC machining centers. The sample we'll be drilling is a very simple flat block of 7075 T6 aluminum. We will go through the process step by step and explain why each is important and builds on the one it follows. In order to machine a hole that is perpendicular to the surface it enters, it is good practice to start with a spotting tool or countersink. This provides a shallow conical starting hole for the initial drill to center itself and not deflect or skid off center. This is especially important when entering an irregular or angled surface. Next, the spotting tool is removed and a conical drill bit goes to work. This drill is pecked at spindle speeds and peck rates determined by the drill and workpiece material. It is critical that the chip created from each peck is not pulled back into the hole. A timed blast of air and oil is used for this purpose. The conical drill is stopped a few thousandths of an inch short of the designed flat bottom hole depth, and the flat bottom drill is required next. That part sounds easier than it is, however. These specialized flat bottom drills must be carefully manufactured by grinding the point of the conical drill bit to a 180-degree flat bottom. Less skilled shops will at times use end mills to perform the final flattening process, but end mills are never flat and are not intended to be used for this purpose. In order to meet the flatness requirement of 1/1000th of an inch per 1/8 inch drill diameter, professional conversion on a specialized Swiss drill grinding machine is essential. The drill flattening begins by removing the point on a large cup wheel. At this point, the tool is flat but will not cut well as there are no cutting surfaces ground onto it. Next, the point is split on the small gashing wheel and the positive attack angle or relief is ground. At this point, the tool bottom is examined prior to going back into the now conical hole. Back to the CNC mill and a few more pecks with the flat bottom drill, and the cone at the hole bottom is now removed and the hole was made dead flat and brought into final depth. Inspection of the flat bottom hole involves several steps. First up, a calibrated gauge pin is carefully fitted into the hole to measure the as-built hole diameter. Next, a flat gauge pin mounted in a pin vise is pressed to the hole bottom and examined on a video measurement system to determine the hole depth achieved. This process is repeated with a second pin whose bottom contains a slightly rounded point. These two dimensions must match or the hole is not flat. In addition to the mechanical inspection using gauge pins, the hole bottom is optically inspected using specialized scopes or vision inspection systems. A final look at the flat bottom drill reveals that the drill is still sharp and has no corner radius, which would reduce the reflective area of the drilled flat bottom hole. On the microscope monitor, you can see the clear difference between a perfect flat bottom drill and the conical bottom drill that begins the process. For visual clarity, we demonstrated this process using a 5/64 drill. However, this process applies to even the smallest flat bottom holes we machine here at PH Tool, such as this number 1 flat bottom hole being drilled in a titanium ASTM reference block. At just over 15/1000ths of an inch, you can imagine the challenge of machining a perfect hole at a depth of 3/4 of an inch without suffering a drill break. Done properly by skilled tool makers on high-quality machines and purpose-built fixtures, the PH Tool team ensures that you are truly getting the standard of excellence.